Well, folks, here it is. It's the video you've all been waiting for, at least those of you who've been leaving comments requesting it. It's the video on how to set up notch filtering. Now, I've got another video I released a few weeks ago on exactly what a notch filter is, and I'll give you a card to link you right to it in the upper right just about now. But knowing what a notch filter is and what it can do for you, and knowing how exactly to set it up are two different things. So this one's going to show you how exactly to set it up. Let's get into it. If we go over to the Betaflight configurator and we go to the PID tuning tab and then we go to the filter settings, we can see that the notch filter, first of all, there's a notch filter for the D term and there's a notch filter for the gyro. So we can apply the notch filter to both of those things separately. The default at this time is that there is no default notch filter on the gyro. The gyro simply has the standard low-pass filter that we've had for a long time, whereas the D term has a default notch filter applied. And I'll take just a minute and talk about why that is. The notch filter parameters have to be tailored for the frequency at which the noise is peaking. So if we look at this image here, and in fact we could even open it in a new tab and zoom in on it a little bit, we can see that there's a big spike of energy or data down here in the, say, sub 20 hertz range, and that's the copter's actual movements, the movements of the frame that the PID controller is concerned with. And then as we look, there's another big spike somewhere else in the frequency spectrum. In this case, it's somewhere between 200 and 300 hertz. It's perhaps a little, or it's close to 250. Oh, and in fact, we can see here, Blackbox Explorer is telling us the peak here is at 250 hertz. So I got that about right. The exact value of that peak is going to depend on many factors. It's going to depend on your motor RPM. And I don't just mean your motor kV, but also literally your throttle value, how fast the motors are spinning. You're going to have a different peak at low throttle versus high throttle because the motors spin faster. The size of your props is going to matter. It's going to change the frequency because the size of the props will also change the motor RPM. Even subtle things like putting foam underneath the flight control board or frame resonance. If you move your electronics from one frame to another, but the electronics are exactly the same, all of this data will change. Okay, so every copter, even two copters that are built identically, are going to have somewhat different spectral data, and the peak is going to be in a slightly different place, and the width is going to be slightly different. So when you set up this notch filter, what you're basically going to be doing is you're going to be identifying where the peak is in the data and how wide the peak is. And you're going to set your notch filter up based on that parameter. So if we look at the parameters for the notch filter, we can see that there's a notch filter frequency, and that's going to be the center of where the notch is deepest. That's going to be the low point of the V, if you will. And the notch filter cutoff, which is the low value where the notch is no longer present anymore. That's sort of the edge of the V, or the top of the V. That all makes sense? It's a V. It's centered on this value, and this sets the width by setting the low point, and it mirrors on the high side. Okay, great. So we need to identify those values. There's an interesting side discussion to be had here, which is if every frame is so different and so many things affect these values, how can Boris just have a default value here that he's applying to everybody? And in fact, for a while, in the early release candidates, there wasn't a D-term notch filter applied by default. And the advice that I and other people gave is that you should not just guess at the values. You need to figure out the values, like I'm going to show you how to do in this video, and you need to tailor it to your copter. But as Boris looked at more and more data from more and more people, he came to the conclusion that it was better to have a relatively wide notch that covered most scenarios, and he found that, in his opinion, it made most scenarios better and few scenarios worse. And so the idea is, instead of having a scalpel, we're going to hit it with a sledgehammer, and that's going to be better than the alternative. Okay, so that's why we have this default here. You'll notice, though, that we don't have a default notch on the gyro. We only have a default notch on the D term. And the reason for that is that Boris found that the majority of setups having a notch filter on the gyro made things worse more than it made them better. The exception to that is that setups where the flight controller has an MPU 6500 chip that may be particularly sensitive to noise in some ways. In those cases, if you're getting symptoms of excess noise, you can try using a notch filter on the gyro, and it may make things better more than worse. For everybody else, though, probably a notch filter on the D term will be sufficient, and you will not need a notch filter on the gyro to get the best performance out of your copter. All right, so the two parameters we need are the notch filter frequency and the notch filter cutoff. How do we figure out what those parameters need to be? The first thing you're going to need to do is you're going to need to enable this command. You're going to need to enter set debug mode equals notch in your CLI. And the reason for that is that if you look at the gyro data in Blackbox, here, let's go do it. Add graph gyros. Here's my gyro data. Here it is. Oh, there it is. There's my gyro data. That's the filtered gyro data. And actually, it's got smoothing applied too. Now we'll turn smoothing off. That's the filtered gyro data. That is not the unfiltered gyro data. And since it's already got a filter applied to it, it's tainted. It can't tell us where the peak of our noise is because the filter is affecting that. Okay, so we need to get the unfiltered gyro data out of the black box, and this is how we do it. We're going to go in here. We're going to go to the CLI. And I'll just, if you don't know a command, try typing get debug, and it'll show you the current value and the allowed values. And then I can type set debug mode equals notch. Okay, and then I would type save, and we reboot, and that's set. Now I go fly. I go fly with my black box active, and when I get back, I'm going to find in Blackbox Log Explorer, there's a new custom field, which is debug. Debug notch. Now I thought there was supposed to be debug 0, 1, 2, and 3. But here there is debug notch. Oh, okay, I got it. It looks like they've changed slightly how it's logged. So here in the custom graph, you've got debug notch, and it adds these 4 elements, which are no longer named debug 0, 1, 2, 3. They're now named gyro raw, gyro notch, gyro raw, gyro notch for pitch and roll. And what these 4 elements are is the raw gyro data before any filtering is applied on the roll and the pitch axis, and the gyro data after just the notch filter is applied, not the low pass, just the notch filter on roll and pitch. Okay, so now that I've got this up, the next thing I'm going to do is I'm going to pick one of these. Let's take a look at the roll axis first. And I'm going to click this little, it's a spectrum analyzer is what it's supposed to be. This little thing right here, I'm going to click it, and it's going to bring up the spectrum analyzer. And then I'm going to click this to make it full screen. And then I'm also going to slide this slider up, and that's just going to rise this up a little bit to make it easier to see. And Blackbox Explorer is telling me that my peak motor noise is at 279 Hertz. And it's telling me that my current notch cutoff values are centered at 260 and cutoff at 160. And so now you want to ask yourself, is this correct for my trace? And it's more or less correct. The peak of the motor noise is definitely contained within the values of the notch filter, and the center is not too far off. Let's take a look. Now we're going to do the same thing, but I'm going to click on the little analyzer icon next to the pitch. Oh, and we can see for pitch, the center is 289 versus on roll it was 279, so it's pretty close. You may find that on pitch and roll yours are different, depending on what frame you're running and many, many other factors. It's pretty close here. And you can see that I have a lot more noise on the pitch axis, and why that might be is a topic for another day. But I have a lot more noise on the pitch axis, but still, basically, if we look at this peak of noise, it's basically contained within my notch filter. Now, if I had just looked at the roll axis, I might have concluded, gosh, I could really narrow this up a little bit, right? This is a little wider than it needs to be. But if we look at the pitch axis, we can see that it's actually kind of just about right, right? It just about is as wide as that motor peak. Now, one of the things I want to point out to you is, do you see how I got all this garbage up here at the top, right? And you might think, do I need to make my notch wider in that respect? And the answer to that is no, because remember, in real life, you have not only the notch filter, but also the low pass filter being applied. At least that's the default configuration. Some people have experimented with running the notch filter by itself with no low pass filter, and if you're one of those people, you probably don't need me to explain to you all the ins and outs of that. If you're running the default configuration, you're going to have a low pass and a notch filter, and the effect of that is going to be that these higher frequencies are being attenuated by the low pass filter. So you can see our gyro low pass is at 90 and our D-term low pass is at 100, which means that the further you get away from those frequencies, the more attenuation there is. So by the time we're up around 400 hertz, we're getting so much attenuation from our D-term and our gyro low pass that the fact that they're not, these spikes over here are not being covered by the notch filter is not such a big deal. So the main goal of the notch filter should be to kind of center on this big, huge spike here and just cut the guts right out of it. And we can see that the settings we've got here are about right and seem to be doing a pretty good job of that. If you find that your peak is significantly narrower on both pitch and roll, you may be able to bring in the cutoff or move the notch center. And this is going to be especially true if you're running lower kV motors, or if you're running 5S versus most of these are tuning, probably on 4S. Anything you're doing that's changing your motor RPM is going to move that center. And anything that significantly moves that notch center may take the peak of the noise outside of the notch. Okay, so if you're running, for example, 9-inch props on a 1400 kV motors, those are very, very low RPM compared to what we've tuned for, and you may find that the notch is down here much lower, and you may want to move this value around. But you have to be really careful not to take one snapshot and tune based on it, and then just go fly and assume that everything is okay. I've heard stories from people who set their notch filter values very, very precisely. And then as soon as anything changed about their copter, suddenly their noise peak was now off by 50 hertz, and a filter that was perfect they didn't have enough filtering at all, and they got hot motors and excess D-gain, and the copter tried to fly to the moon. So be very, very careful about tuning your notch filter too precisely. You always want your notch filter to be a little bit wider, or maybe even a lot wider than you really think it needs to be. Because anything could change your motor RPM, change your spectral characteristics, and if your notch filter is very, very narrow, that could be the only thing that's keeping your copter flyable, and as soon as the noise frequency changes, then the copter could become unflyable. By default, this spectrum analyzer shows you the first 5 minutes of the flight, which for most of us is going to be pretty much the whole flight. So you can actually see the effect of the changes that occur during flight, for example, high throttle versus low throttle, by using the I and the O button to set the in and out points in Blackbox Log Analyzer. So let me turn off the spectrum analyzer here real quick, and let's just look. For example, we can see something is changing with my noise here versus here. Now probably my throttle went up. That's the most likely thing. But let's press I to set the in point and O to set the out point. And now if I turn on the analyzer, I'm only looking at the noise from this one little segment. Now I'm going to need to really bring this up, but you can see first of all there's not much noise at all. But you can see that the peak now, such as it is at around 127 hertz. Okay, so if you want to really explore this in a little more detail, what you can do is you can use the I and the O button. Now I'm going to go to the beginning and press I, and go to the end, press O. That's the only way I know to clear the in and the out points. You can use that function to test different scenarios. You can say, where is my motor noise peak when I'm at high throttle versus low throttle? Well, you can sort of test those different scenarios out and compare them and see what kind of a difference they make, either by logging different logs or using the I and the O button to select a subsection of a log and see how much that changes these values. And what you'll probably end up finding, if Boris has done his job, is that most of the time your noise is around these values. Okay, so you may find that these values by themselves work pretty well for you, and that doesn't actually require much tuning. Betaflight defaults fly really, really well for the vast majority of people, especially if you're flying a 5-inch mini quad 4S, which is what a lot of people who are doing the tuning are tuning on. All right, so let's sum up. You want to set the center of the notch to coincide roughly with the peak of the motor noise, and you want to set the width of the notch more or less so that the entirety of the motor noise is contained within the bounds of the notch, so that the notch cuts out the motor noise and not much else. The peak and the width of the motor noise is going to be different on the pitch axis than the roll axis many times, and it's going to change in flight as your throttle value changes, as other characteristics change. So you probably don't want to try and tune that notch too precisely, especially because you only have one notch available for both the pitch and the roll axis. So if the peak is slightly off for the pitch and the roll axis, or if the width is slightly off, you're going to have to just split the difference. The default value does a pretty good job of this, and the conclusion that Boris has come to, as evidenced by the default values he's come up with, is that it's better to let the notch be a little bit too wide and not quite as precise, and that will still do a great job of cleaning up the data on a variety of flight conditions. If you switch props, for example, the notch will still be okay. If you want to go from tri-blades to quad blades or whatever, or if you're trying different things, having a wider notch is better than having a narrower notch. A little bit of attenuation all the time is better than a perfectly precise attenuation that then becomes completely incorrect when you change the tiniest little thing. A D-term low pass combined with a D-term notch and a gyro low pass with no notch on the gyro is what Boris has decided is the best all-purpose case. Some people have experimented with a notch filter on the D-term and no low pass. If you're not the kind of person who is really trying to tune out the last tiny bit of prop wash, right, you're probably not going to notice a difference, and you should probably just stick with the defaults. But if you're trying to tune your copter to the nth degree, you may find that you can get slightly better D-term performance with less latency and a slightly greater risk of hot motors by disabling the low pass and using just the notch filter on D-term. Again, that's an advanced move. Not everybody should try it. In general, you should not need a notch on your gyro unless you have some particularly noisy environment, like if you've got an MPU 6500 that is experiencing noise issues. You may find an improvement by going to the gyro notch. But I would recommend trying to find mechanical solutions first, such as soft mounting the flight controller. The notch should always be like a last resort because it adds latency. And anytime you add latency to the flight controller, you're decreasing its ability to help the copter fly well. And that's it. Now you know how to set up the notch filters. For most people, the best advice I could give you is leave the defaults alone. Check. Go into Blackbox and check to see if the defaults are about right for your copter. And you'll probably find, as I did, that the defaults are about right. And that's the great thing about Betaflight. You have all the knobs and dials and buttons if you want to spin them. But a lot of the times, the best thing to do is to just go fly because the defaults fly pretty darn well. That's it for now. Happy flying.